Hi, and welcome to Woodbridge Geometry Virtual Tutor. In this lesson, we're going to concentrate on the unit congruent triangles, where our objective will be being able to prove that two triangles are congruent using one of the 5 postulates listed below. Before we get started, there are some special corresponding parts that we need to talk about. When proving that two triangles are congruent, you might use one of these two vocabulary words here. The first one is vertical angles. Vertical angles are corresponding angles that share the same vertex point. These angles are equal. The reason we want to know about this is this can help prove that two triangles are congruent by adding extra evidence. Now, they're not going to tell you that these two angles are congruent, but you are allowed to assume that these two are. For example, in the picture provided, you can add that this angle and this angle are congruent to each other because they are vertical angles, and vertical angles are always equal to each other. So it adds more evidence to your picture. The second item is what we call a reflexive side. A reflexive side is a side length that is shared between two triangles. The side length is equal in both triangles. For example, in the picture above, we're told that we have two sets of congruent sides, but you can find a third set. It is this shared side between the two triangles. So we can add that to our evidence list. These are not always going to be featured in every single problem or picture, but they could be present, so you want to look out for them. Now, how do we know two triangles are congruent? Two triangles are congruent if and only if the 3 sets of corresponding angles are congruent and the 3 sets of corresponding sides are congruent. If you remember from our previous video, we said that with two triangles being congruent, there are 6 sets of corresponding parts, 3 sets of angles and 3 sets of sides. Well, if the two triangles are congruent, that means the 3 sets of angles are the same and the 3 sets of sides are the same. So all 6 sets of corresponding parts must be congruent in order to prove that two triangles are congruent. However, you don't need to prove all 6 sets. To prove that two triangles are congruent, you do not have to prove that all 6 sets of corresponding parts are congruent. There are 5 possible shortcuts that you can take. The key number to get to is 3. If you can prove that 3 sets of corresponding parts are congruent, and if they make one of the 5 possible shortcuts, then you can prove that the two triangles are congruent. Let's take a look at the first two. The first one is what we call triple S or SSS. That stands for side, side, side. And in triple S, if you can prove if the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. So if you can prove that the 3 sides of one triangle are congruent to the 3 sides of the other triangle, then that's enough evidence to say that the triangles are congruent. Reason, triple S. In the picture provided, we're told that it has one set of congruent sides, it has a second set of congruent sides, and we can find a third set of congruent sides because they have a reflexive side. The second postulate is SAS, which stands for side, angle, side. Now this means if two sides in what we call the between angle are congruent, then that's enough evidence to say that the two triangles are congruent, so all 6 sets of corresponding parts are congruent. Now what I mean by the between angle is, it is the angle that is created by the two sides. It has to come in that order. It has to be side, the next angle, and then the next side. If we look at this picture right here that's provided, we see that we have one set of congruent sides, and then we have a second set of congruent sides. Well, look to see if you can collect any more evidence. We're not told anything else, but we can find that they have a set of congruent angles because those are vertical angles. So we have two sets of congruent sides and a set of congruent angles, and they go in the order side, angle, and then the next side. So we can prove that these are congruent because of SAS. The third postulate is ASA, which is angle, side, angle. And this postulate states if two angles and the connecting side are congruent, then the triangles are congruent. What do I mean by the connecting side? The side that connects the two angles. So in the picture provided, if you look, we have one set of congruent angles, we have a second set of congruent angles, and then the side that connects those angles in both triangles is the same measure as well. Because we have two sets of congruent angles and a set of congruent sides, and they go in the order angle, side, then the next angle, you can prove that those two triangles are congruent using ASA, angle, side, angle. The fourth way is what we call AAS, which stands for angle, angle, side. If you can prove if two angles and an adjacent side are congruent, then that's enough information to say that the two triangles are congruent then. In the picture provided, we have a set of congruent angles right here. We have a second set of congruent angles listed right here. And then we have a reflexive shared side. So we can say that these two sides are the same because they're being shared between both triangles. And if you look, the order goes angle, the next angle, and then the next side. It goes angle, angle, side. In other words, AAS. It goes in that order. The last one is what we call HL, which stands for hypotenuse leg. If the hypotenuse and a leg of a right triangle are congruent, then the triangles are congruent then. It has to be a right triangle. If you remember our parts of a right triangle, you have the two legs, and then you have the hypotenuse, which is the longest side, which is the side across from the 90-degree angle. Well, if you can prove that you have two right triangles and the hypotenuses are the same, and they also have a leg in common, you can prove that these two triangles are congruent then, and all corresponding parts are congruent. In the picture provided, you can see that we're told that we have two right triangles here. Okay? Across from the 90-degree angle is the height. So we are told that the heights are the same. And then it has a shared reflexive side, which is actually a leg between both triangles. And we're told that they are the same measure. So they have a hypotenuse that's the same and a leg that's the same. So we can say that those two triangles are congruent because of HL. Now, there are also two shortcuts that do not prove that two triangles are congruent, but they're often used as trick answers and trap answers in multiple choice questions. Now, a triangle could be congruent using one of the 5 previous theorems that we just talked about, but you could also have your answer as not congruent if one of those does not apply or it makes one of these two. So you have SSA or ASS if you go backwards, which stands for side-side angle or angle side-side. A picture is provided. If it makes this order, this is actually a way that two triangles are not congruent. It's not enough information. The second way would be triple A, angle, angle, angle. If you are told or if you prove that the 3 angles of one triangle are congruent to the 3 angles of another triangle, it's actually not enough information to prove that the 2 triangles are congruent. So you want to watch out for these as possible answers in multiple choice questions. If you see them, you can cross them off right away because they cannot be right. Questions to expect. Questions to expect are questions where I'm going to give you 2 triangles and markings or measurements about those triangles and ask you, can you prove to me that they are congruent? And if so, what is your reason why? What I mean by your reason why is what theorem or postulate would you use to prove that these 2 triangles are congruent? When answering these questions, the first thing I recommend to look for is, does your picture have reflexive sides and or vertical angles? If they do, mark it congruent. In this first one right here, okay, in this first example, I notice right away that we have a shared reflexive side. So I'm going to mark those congruent. Now there's nothing else that I can mark congruent myself, so I'm going to collect my evidence. I see that we have 2 sets of congruent sides and a set of congruent angles. So I have 2 S's and an A. Now the only one that pops into my mind that could work is SAS, side, angle, side. But now I have to check, does it go in that order? It goes side, the next angle, and then the next side. And it's SAS in both triangles. So I can say, yes, these 2 triangles are congruent by side, angle, side. In the second example here, I don't see any reflective sides. I don't see any vertical angles. So I just look at the evidence given to me. Okay, these markings tell me that the angles are congruent. I have 3 sets of congruent angles. Now I remember from my list, that's a reason that tells me that 2 triangles are not congruent. Triple A does not work. So I would say no, these are not congruent. In the third example here, okay, we have 2 triangles. I see that we have right angles. We have a set of congruent sides as well. And I notice that we have vertical angles right here. Okay, so we have 2 sets of congruent angles and we have a set of congruent sides. Okay, so we have 2 90-degree angles. We have the vertical angles and we have the set of congruent sides right here. So we have 2 A's and an S. This could be AAS or it could be ASA. It could be one of those 2. Well, let's check to see what order it comes in. Okay. It goes angle, angle, and then side. So I can say, yes, these are congruent by angle, angle, side because it is in that order. In the fourth example right here, let's take a look. I notice right away we have a reflexive side, so I'm going to mark it congruent. There's nothing else that I can mark congruent, so let's look to see what's given to me. I notice that I have 2 sets of angles that are congruent, and I have a set of sides that are congruent. So I got 2 A's and an S. This could be AAS or it could be ASA. Well, I look, It goes angle, side, angle. So I can say, yes, these are congruent by ASA, angle, side, angle. At this point, I would like you to pause the video and practice these 4 questions and prove that these 2 triangles are congruent. And if so, tell me the reason why. If you feel that they are not congruent, then you will write not congruent. Please pause the video now, and when you are done, you may hit resume, and we will go over the answers. Now that you have finished these you try problems, let's take a look. For the first one, no reflexive sides, no vertical angles, but we have 3 sets of congruent sides. Okay. That is enough to say that, yes, these are congruent because of side, side, side. In the second one here, okay, no vertical angles, no reflexive sides. I have 2 sets of congruent sides and a set of congruent angles. And I notice they go in the order side, angle, side. So I can say, yes, these are congruent by side, angle, side. In the third one, in the bottom left corner here, I notice right away I have a reflexive shared side. I have a set of congruent angles and I have a set of congruent sides. Now that's all the evidence that I can collect here. And unfortunately, it should not have been enough evidence to prove that these 2 triangles are congruent, so your answer should have been not congruent. And then the last one, I notice right away that we have a shared reflexive side. I also notice that we're dealing with 2 right triangles, so that's a good indication that we might be dealing with hypotenuse leg, or HL here. So let's take a look. If I look, the shared side, the shared reflexive side, is actually the hypotenuse for both triangles. Well, since it's a reflexive side, it's congruent. And when they also have a leg in common, so your answer here should have been yes. These are congruent by HL, hypotenuse leg. I would like to take the time to thank you for watching this video on congruent triangles.